In recent advances in artificial intelligence, particularly with large language models, researchers have been exploring ways to simulate social interactions through multi-agent systems. One exciting new development is the BookWorld system, introduced in a paper titled BookWorld: From Novels to Interactive Agent Societies for Creative Story Generation, by researchers from Fudan University. This work shifts the focus from creating agent societies from scratch to building them based on established fictional worlds from books, which offers significant practical value for storytelling and beyond. The paper begins by highlighting how large language models, or LLMs, enable the simulation of social dynamics. Previous efforts have mostly involved designing agents with new personas, like in social simulations or task-oriented systems. For instance, some studies look at agents debating or playing strategic games, while others focus on collaborative tasks such as coding or generating stories from generic prompts. However, the authors point out that simulating well-known fictional universes, think of characters and settings from classic novels, has been largely overlooked. This is where BookWorld comes in, as it provides a comprehensive framework to bring books to life through interactive agent societies. At its core, BookWorld is a system that extracts data from source books and uses it to construct a multi-agent environment. The process starts with gathering character information, such as their personalities, backgrounds, and relationships, along with broader elements like the world's geography, social norms, and cultural contexts. For example, if you're working with a fantasy novel, the system would pull in details about magical elements, historical events, and even terminology to ensure everything feels authentic. Once the data is extracted, BookWorld builds a society of agents. There are two main types: role agents, which represent the individual characters from the book, and a world agent that oversees the entire simulation. Each role agent has its own memory, status, and goals, which evolve as the simulation progresses. For instance, a character might have a goal to explore a forest or resolve a conflict, and their actions are influenced by factors like their location on a map. The simulation itself unfolds in scenes, much like chapters in a book. Agents in the same location can interact, through conversations, trades, or conflicts, based on their predefined traits and the world's rules. The map is designed as a discrete graph, meaning locations are connected, and agents might need to spend several turns traveling between them. This adds a layer of realism, incorporating geographical constraints and changes over time. Meanwhile, the world agent acts as a conductor, managing the flow of events, updating global status, and providing feedback to keep everything consistent with the source material. One of the key innovations is how BookWorld handles the fictional worldview. Books often include fantastical elements, so the system systematically collects and integrates data on social norms, cultural details, and explanations of unique terms. This ensures that agents behave appropriately. For example, a medieval knight in a fantasy world wouldn't suddenly act like a modern CEO. As agents interact, their experiences are recorded, and at the end of a simulation, these histories are woven into a cohesive story. Large language models then polish this into a narrative that reads like a novel, complete with creative extensions while staying faithful to the original book. BookWorld isn't just for passive generation, it supports interactive applications too. Users can intervene in the simulation, perhaps by specifying plot twists or scripts, turning it into an interactive game or social experiment. This makes it versatile for things like educational tools, where students could explore historical fiction, or entertainment platforms for fans to extend their favorite stories. To evaluate BookWorld, the researchers conducted extensive experiments. They compared it to previous methods for story generation, focusing on aspects like creativity, quality, and fidelity to the source material. The results were impressive, with BookWorld achieving a win rate of 75.36% in head-to-head comparisons. This means that in most cases, stories generated by BookWorld were preferred for their originality and accuracy. The paper includes a preview figure showing characters interacting in locations like a castle or forest, demonstrating how the system visualizes and manages these dynamics. The authors also emphasize the broader implications, drawing from literary references like Justine Garder's Sophie's World, where characters question their existence in a book. By using LLMs, BookWorld allows fictional characters to live beyond their original pages, fostering new ways to engage with literature. Finally, the code for this system is publicly available on their project page, encouraging further exploration and development in this area. This approach not only advances AI-driven storytelling but also opens doors to more immersive experiences, blending technology with the timeless art of narrative creation.